Okay, so let's start off continuing from last week. So last week, what we did was we set up these iteration algorithms, right? And the idea behind the iteration algorithms is to say, if I have a differential equation, I can march forward in time, right, just by setting up some appropriate iteration scheme based on Taylor expansions. That's it. And then the last lecture we talked about is not only do I know how to set up the iteration scheme, I can, in fact, decide what kind of error I want and also the stability of the scheme. Okay? So we're going to put this into practice, especially Wednesday. But one other problem I want to talk about today is a boundary value problem. Okay? So these are fairly common. Let me write it down. And in some sense, you already have an intuitive sense how to solve these things. Okay, so I'm going to go ahead and write something down. This might be something like some kind of, let's write down like a second order differential equation. And here's the deal with this. Unlike what we had before, where we said, okay, if I solve this differential equation, I specify the state of the system at, let's say, time 0, and I march forward into the future. Here, it's a boundary value problem. So I've still put t here. T is still a dummy variable. It could mean time. It could mean space. It could mean anything. Okay? And really but now what the boundary value problem has is something like this. You specify some endpoints. So I'm going to solve this differential equation from time is in some interval, let's say a to b. Okay. So I'm going to solve this thing from time a to b, and at time a, I impose this condition, and at time b, I impose this. So for a second order differential equation, to solve it, you have to impose two conditions. For a first order differential equation, one condition. For a third order, three conditions. For a fourth order, fourth condition. For a fifth order, yeah, you got the pattern. It's awesome. Okay. It changes at 17 where you have to specify 19. I'm just kidding. Okay. No. So there we go. So whatever the order of differential equation, you have to specify that number of conditions on it to nail down the solution uniquely. Okay? You can still get a solution. It's just that you have an infinite number of them. So here, when you specify that, there's one solution that comes out of this thing, and you are trying to construct that. Yeah.
Endpoints, or can it be like A in the middle?
Typically, what happens is you either specify at the left, like you march it forward in time, or if it's a boundary value problem, you specify it at the two endpoints. Yeah. That's normally the way people do that. However, if you wanted to set something up where you specify halfway across some, you could do that too. All right. So let's make this a little simpler. And let's start off. In fact, here's a generic form, let's say the most general form of the boundaries that are typically written down. I'm going to make something a little bit easier. I'm going to start off with, again, second order differential equation. With this function f, which is a general function like this. It's generically nonlinear, let's say. But now let's make very simple boundary conditions. So really, you're looking for some solution in some interval, t, and you specify that at time a, it's alpha, and it does something funny around here, and then it ends up with, at the other end, with beta. Okay? So in between, it has to satisfy this equation, and at the boundaries, you have to constrain it to here. So this is sort of the generic way to think about doing that boundary value problem. Okay? All right, so that is the algorithm. Now, let's try to tie this in to what we've been doing previously. So previously what we said is the way these iteration schemes worked is I had to specify the state of the system and march it forward into the future. So you give me the state of the system at some time, and from there, I can march forward into the future with, like, say, Runge-Kutta OD45. I march it forward. I've specified everything to begin with. I have nothing left. Normally, in other words, I cannot take off on Runge-Kutta unless I specify everything at the beginning. And this says, well, I haven't specified everything at the beginning. Some of it I've specified here, some over there. So how do I make sense of using the techniques we've already developed with this thing here? Okay? Because this thing here is saying, well, I'm specifying things here and into the future. It's a little bit like I'm specifying one thing, I start marching forward, and I'm supposed to hit a target. And that's exactly kind of what, this is the way we're going to use this routine.